Okay, for lesson 13, first thing we're going to talk about is some rules about secants and chords and tangents. It says here, if two secants or chords intersect inside a circle, the measures of the angles formed are equal, should be are equal, to the sum of the measures of the intercepted arcs divided by 2. So it's the sum divided by 2. The sum of the measures of the intercepted arcs. So let's get an example here. So we'll do two chords. They could be secants, but we'll just do chords. They're intersecting inside a circle. It says the measure of the angle formed. So like, let's put X right here to represent the measure of that angle. We know that angle right here is congruent, so it'll also be X because they're vertical angles. If this arc right here was 40 degrees, and say this arc right here was 50 degrees, then it says the measure of the angles that are formed will be equal to the sum of the measures of the intercepted arcs. So we're going to add the 40 and the 50, and it's divided by 2. So that's going to be what the measure of angle X is. So that's 90 divided by 2. So of course that's 45 degrees. Okay. The next one says if two secants intersect outside a circle. So let's draw a picture. Now we know that secants go through the circle, and these are intersecting outside. So let's let them intersect out here. I'm drawing down here. So the intersection is right here. It's outside the circle. This one was inside the circle. So I'm going to call this right here arc. I'm going to call it A, and I'm going to call this arc right here B. Now these angles that are formed by this intersection are going to be the same. I'll put my measure out here just because it's easier to read. So the measure of these angles that are formed is the difference of the intercepted arcs. So it means we're going to subtract them, and then divided by 2. So that's very similar to the other one, but these are intersecting outside. So it's going to be the measure here of angle X is going to be B minus A divided by 2. Of course, you'd be the large one minus the smaller one. So the difference of the intercepted arcs divided by 2. So notice that if they're intersecting inside the circle, you add the 2 arcs and divide by 2. If they're intersecting outside the circle, you subtract them and divide by 2. Okay, and what if it was a secant and a tangent? So what would that look like? That would look like this and possibly this. They're intersecting outside here. So we need to identify what our arcs are. So let's call from here down to this point of intersection, we'll call that C. And then from here down to this point of intersection, we'll call D. And again, I'll put X right here. Now we're going to follow the same rule, because it really doesn't matter if it's two secants, a secant and a tangent, or you're going to find in a minute, or two tangents. So we're going to take the larger one, subtract the smaller one, and divide by 2. If it's two tangents, it might look something like this. That's not the best drawing, but you get the message here. Okay. Now here with two tangents, we know that these two arcs that I'm going to label here are going to create the entire circle together. Now, this arc here would be a minor arc because it's less than 180 degrees. So I can call that arc EF. But this arc over here would be a major arc. So I would need to add another point. Okay? So now the measure of angle X, I'm going to take the larger one, which would be the measure of the arc EGF, use the arc symbol, minus the measure of the arc EF, again with the arc symbol, and divide it by 2. Now, this one had 3 letters because it's a major arc, and this one had 2 because it's a minor arc. Okay? And if 2 chords are intersecting in the interior of a circle, okay? So we've already talked about that with measurement of angles, but now this one's actually going to have to do with the measurement of the chords. It says, then the product of the segments of the chords are equal. So let's call this measurement right here little a, and this part here little b. And this measurement, this part here little c, and this part little d. So this is one chord. The segments of this chord are this segment and this segment. This is a chord. The segments of this chord are this one and this one. So it's the product of the segments. So A, B would be equal to C, D. Okay, moving on to number 4. And this one says, if 2 secant segments intersect outside a circle. So let's get a picture again. So let's do this. Now they may continue out this way. I'm just not having them continue. And they may go past this point, but you know, everything doesn't always look the same. So getting a little bit of variation in some of the sketches might be helpful. Okay, it says if 2 secant segments intersect outside a circle, then the outside length times the whole length of each segment is equal. Now what does that mean? So let's put some example here. Let's call this distance 3, this 5, this 2, and this x. So it's saying when they intersect outside, that this section outside, the outside length, times the whole length, which is 3 plus 5, is going to be the outside length times the whole length, which is 2 plus x. And then, of course, we would solve this. Okay? So you notice that when we got to number 3, we changed from talking about angle measures to lengths of segments, right? And we got one more. And that's if 2 tangent segments intersect outside a circle. Again, we're talking about the lengths of segments now. Then, so we have this point of tangency and this point of tangency. That's what those are called. And this is where they're intersecting. Okay, then the lengths of the tangent segments are equal from their intersection point to their points of tangency. So this diagram has more on it than you need, because sometimes that's just the way it looks. So we're talking this right here, from the point of tangency to the point of intersection. From the point of tangency to the point of intersection. So this is the part of the diagram that we're going to focus on. And what it is saying is that these are equal. So hopefully this is a good review of these geometry theorems.